And one is just like the general probability and odds section, and then we're going to narrow down into something called permutations and combinations. The good news is you'll also get this again. Like I teach this in pre-calc, so we'll teach it again, and they'll teach it again in Algebra 2 Honors. By the time you go to take your actual SAT and your ACT, hopefully this will be nice ingrained inside your brain. Okay, so the definition starts with a couple just vocab terms. The first thing is called an outcome. So an outcome is the possible result of an experiment. So, for example, when you roll in a die, which is like a single dice, a die, the outcomes are rolling a 1, a 2, a 3, a 4, or a 5, or a 6. Okay, those are the outcomes. When you flip a coin, the outcome is either heads or tails. An event is an actual activity, so an outcome or a collection of outcomes. So, if I wanted to roll an even number, that's called an event. What am I trying to do? Okay. If I wanted to flip a coin and if I wanted to land on heads, that would be an event. And a sample space is the set of all the possible outcomes. So 1, 2, 3, 4, 5, and 6 are actually the possible outcomes. Heads and tails are the possible outcomes. Those would be your sample space, all of the different possible outcomes. So you're not going to be asked like to define these terms, but you're going to see things like what are the possible outcomes or what's the sample space, and this is why you need to know those terms. Okay, so example 1 says if you flip a coin twice, how many possible outcomes are in the sample space? And list the possible outcomes. So I actually do this in reverse. I do the listing first and then just count what the listing is. So if I'm going to flip a coin twice, right, I've got all these different possibilities. I can get tails both times. So you can get tails and tails. You can get heads and heads. You can get tails the first time, heads the second time, heads the first time, tails the second time. So these are these are the sample. This is your sample space, right? All of these 1, 2, 3, 4 different possibilities. So there are 4 outcomes. And then that is those are all the possible outcomes. It doesn't have to be in that order, okay? B says you flip a coin and roll a number cube. How many possible outcomes are in the sample space? List the possible outcomes. So you have 6 sides on your number cube, which means you can roll 1, 2, 3, 4, 5, and 6. That would be the number part of it. But then it says you're also going to flip a coin. So you can get a tails each time. A tails and a 1, a tails and a 2, a tails and a 3, a tails and a 4, a tail and a 5, and a tail and a 6. Or you can roll a head. You can flip a heads. So these are all the different possibilities in the sample space, and it says how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, probability of an event. So the probability and odds are 2 different things. Probability is the likelihood or chance that an event's going to occur. Probability is a number between 0 and 1. So it's a decimal, or it can be written as a percent or a fraction. So those are the 3 ways that you can write probability. If the probability is 0, then it's impossible. So if I said something like flipping or rolling a die and landing on a 10, that's going to be impossible. There's not a side that has 10 on it. So that would be 0 out of 6. The probability of a 1 means it's a definite, it's certain. So that's like rolling a number that is less than 7. Every single side on your die is less than 7. That would be 7 out of 7 or 6 out of 6 or 1 out of 1. Again, it can be written as a fraction, as a decimal, or a percent. So if I had something like 1/2, it could also be written as 0.5. It could also be written as 50%. All of those are probability. And the notation for the probability of event A is P parentheses A. That's probability of A. Again, the closer to 0 it is, the harder it is for that to happen. The closer it is to 1, the more likely it is to happen. Questions so far? Okay, theoretical probability can be found when all the outcomes are equally likely to occur. So for example, a die, it is equally likely to roll a 1 as it is a 2 or 3 or 4 or 5 or 6. So in order for these to be like the probability, to find probability, we say that these have equal outcome. Okay, it's not like a weighted die or a weighted coin, right? Then that's different. It's like the lotto. It's like flipping a coin. All of those would have equal value. So the way you find it is you put the number of favorable outcomes, so what you're trying to get, how many of those are there, over the total number of outcomes. So if I take a coin and I flip it once and I want to get heads, then it's 1 out of 2. 1 because there's only one side that has heads on it. 2 because there's 2 possible outcomes. If I roll a coin and roll a die and I want to land on a 2, there's only one side that has a 2, but there's a total of 6 sides. So that probability would be 1 over 6. All right, example 2. You toss a coin and roll a number cube. This is the same thing as a die. What's the probability that the coin shows heads and the number cube shows 5? So remember we did these. This was the T1, T2, T3, T4, T5, T6, because you're doing a coin and a number cube, or H1, H2, H3, H4, H5, H6. So the bottom number is how many are there, which is 12. There's 12 different possibilities. The top number is how many are going to match what we want. So how many have heads and 5? There's only one of those. So it's 1 out of 12. So your answer can either be 1 out of 12 like that, which is actually exact. That's probably preferable. Or if it gives it to you in decimal form, you would just do 1 divided by 12, which is 0.08. And if you did it in percent, it'd be 8%, because you move your decimal place 2 places to the right. B says, what's the probability that a student chooses a t-shirt with a gold emblem? So now we've got a chart. This is what, like, ACT loves charts. We've got a chart, right? And it's got golden emblem, silver emblem, and then a green t-shirt or a red t-shirt. So total is all those shirts added up. So 10 plus 8 plus 6 plus 6 tells me that there's a total of 30 shirts. Now I want to know one that has a gold emblem. So gold emblem, whether it's green or red, is that entire row or that entire column. So I'm going to say 10 plus 6 would be 16. And so this would be 16 over 30 or 8 over 15. So you want to make sure you always reduce it. 8 divided by 15 could also be 0.53 or 53%. So unless it says specifically to enter at a certain one of those, you would take more than one of those as the answer. That's the worst percent symbol ever. Everybody still good? Okay, experimental probability is based on repeated trials of an experiment. So we flip a coin 3 times, or we roll a die 5 times, or we spin a wheel more than once. That's an experimental probability. The number of trials is the number of times the experiment is performed. So if it's like 3 times, then we say 3. Success is each trial in which a favorable outcome occurs. So if I want to spin a wheel 3 times, that's going to be 3 in the bottom, and how many times I get what I want is what's going to go in the top. So example 3 says each section of the spinner shown has the same area. The spinner is spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical? So experiment is based on this data. We actually performed this 20 times, so the 20's in the bottom. And if I want to get red, then it's 5 out of 20. So this would be for red. If I want to get green, then it's 9 out of 20. If I want to get blue, then it's 3 out of 20. And if I want to get yellow, it's 3 out of 20 as well. That's the experimental, so that's based on the data that was actually done. Now, which is the same as the theoretical? Theoretical is just look at your spinner. What are the chances of landing on red? How many of those parts are red? 1, right? And how many total parts are there? 4. So the theoretical is 1/4 for each of these. So experimental based on actual data, theoretical based on your initial, whatever the sample space is, whatever you're given at the beginning. So this question says, for which color is the experimental probability the same as the theoretical? And it's red, because 5 over 20 would reduce to 1/4. That's the only one that they would both be the same. Okay, last thing, and then we're almost done. We're so close. Is odds. So odds and probability are different. Probability is always what you want over the total amount. So probability is always over the total. Whereas odds, the top and the bottom add up to the total. So the odds, you don't count what you put in the top for the bottom. It's what you want over what you don't want. That's odds. So the odds of an event compare the number of favorable and unfavorable outcomes when all outcomes are equally likely. The odds in favor, so like if I wanted to roll a die and I want to get a 3, the odds that I get a 3 are 1 to 5, because there's 1 3 and there's 5 sides that don't have a 3. The odds against are the reverse. So the odds against, if I want to get a 3, there's 5 against 3, so it would be 5 in the top, and there's only one side that has 3, that's in the bottom. So against means what would happen if you don't, how many options are there if it's not what I want? That would be odds against. And again, top and bottom here should always add up to the whole number of sample space that you've got for odds. So A says in example 3, find the odds against stopping on a 3. On a green. So if you, this goes back to our spinner, right? So there was a red, oh, thank you. Okay. So in that spinner example, there was a red, a green, a blue, and a what? And a yellow, right? Yeah. Okay. Not necessarily in that order. But if I want to find the odds against stopping on a green, I want to say how many things are not green. God bless you. And it's 3. How many things are green? 1. That's the odds of going against a green. The odds in favor of a blue, I want to figure out how many options there are that are blue. There's 1. Over how many options that are not blue? 3. Easy stuff, right? You just got to remember that odds you have to take away, like, remember, it's not all of it, where the probability would be 1/4 here, or 3/4. Odds, you don't count whatever it is you're trying to count on the top. Sure. Everybody else good on this? Okay, if you're good, go ahead and head out. Your homework for 12/1 is due on Tuesday. Have a great weekend. And then, bye, guys. Have a great weekend. Yeah?